So this is our day 21 while loop warm-up. All right, I'm assuming you're done with that. We're going to do notes now. We're going to learn about another kind of loop. It's called a for loop. A for loop has three parts. An initialization that's executed once before anything happens, and then a Boolean expression that is evaluated before any code inside the block is run. And think of it like this: run this loop as long as this is true. That's what that means. And then finally, there's some sort of incremental statement that changes a variable so that the for loop can end someday. So I'll show you what I'm talking about. Right here, here's a for loop. Your first for loop, if you haven't coded in Java before, the parts, this is, you have the word for and then a set of parentheses, and then you have the initialization, and then the Boolean statement and the increment statement. Everybody stop working on the warm-up and look up here. This is more important than the warm-up. The answer to the warm-up is going to be the start of today's notes video, so I put it right on there. You can fix it later. I can help you before we leave. We have 27 minutes. So this prints 0, 1, 2, 3, 4 because I starts out at 0 and it's going to go as long as it's less than 5. And it goes up 1 each time. So if the Boolean expression is false to begin with, it never runs the loop. It doesn't. So you're not guaranteed that it's ever going to run anything. But it checks and then it goes in and runs it, and then it does the increment statement, and then it checks to see if it should run it again. So that's the way it goes. The increment statement can be a decrement statement too. That means going down instead of up. So this one starts at 8 and keeps going as long as I is greater than 4 and goes down by 1 each time. So it goes 8, 7, 6, 5. And here's something. Any for loop could be written as a while loop and vice versa. So it's not like they're not exclusive. We'll talk a little bit later about when one is better than the other. But here's that one I just showed you as a for loop, and here it is as a while loop. So you have to declare the variable ahead of time, but you declared it right here on the for loop. And you have to say keep going as long as I is greater than 4. You said that here. And you have an I minus minus, you have an I minus minus. It kind of just takes all the pieces and puts them in different places. But it does the same thing. A new concept for us in this class is scope. And that's the block of code where a variable is valid. So in the craziest sense, let's say we are all working on a project and each one of us had a file of code we were turning in, and they all got combined into some massive project. If Caleb used a variable called X and I used a variable called X, that's okay because Caleb's is in his file and mine is in my file. Now, in a single file, we have the same issue. And what that is a variable is only valid within its scope, and the scope is the braces that hold it. So here's an example of, here we have int I equals 8. We have our little for loop. And then down after the for loop, I try to print I. And this code won't even compile. It says, I don't know what you're talking about I. There's no I defined. And you're like, what? I defined I right here. But this I variable only lives inside of this for loop. That's the only place you can access that I. And in fact, that's why we often use I. It's just sort of a Java convention to use I for the for loop. If you always just think, well, whatever, I'll use I for the for loop, then you don't have to make a big decision ever. And you would not then, and I shouldn't be, you shouldn't try to use it outside of the for loop because, so I just use I as a throwaway variable in all my loops, but I don't use it in other places. But so this code won't even compile because we're trying to print this variable I after the for loop, and that variable I only exists inside the for loop. This can also happen if you define a variable inside of an if statement, inside of the braces of an if statement, or a while loop. If you define a variable in there like int I equals or int my most important data equals, then later you can't access it. So things you want to be able to access anywhere, you tend to define up above all your loops and things. That's the bottom line. This also goes for methods. If you have a method that creates new variables, they only exist in that method. And when you return or leave the method, those variables just go away. So I fixed this problem. Notice I said int I equals 0 above the for loop. And then instead of saying int I equals 8, I just said I equals 8 because I already exists. And that way I does exist down here. That's different from this one where I got declared in the for loop itself. Whereas right here, I declare it before the for loop. Not a big deal. Here's a question, and we're almost done. When is a for loop better than a while loop? I would say in general, if you know exactly how many times you want to run. So, for example, let's say you were going to write a program like that averager program, and you were going to say, hey, I want the user to enter numbers until you don't want to anymore. That's not a great use of a for loop because you don't know how many numbers they're going to want to do. That was perfect for a while loop. But let's say you have 100 students in a big list and you want to go through each student. A for loop's perfect. You say, hey, run this list, run this loop on these names. I know exactly how many I want. That's a totally different thing. Or if you want to go through every character of a piece of text and check it for something, that's perfect. You know how long the text is, you use a for loop. But anything that's more open-ended, a while loop might be better. But remember, you could do each thing. It's possible. Like if you wanted to do our averager program with a for loop, you would probably just say, make the for loop go 1,000,000 times. You think, no user is going to sit here and type 1,000,000 numbers. So, and then the break would still leave the loop just like it did. Okay, so I now got 3 little practice problems. I'm going to ask you to figure out what will be printed by this. So look up here and try to figure it out without saying it out loud. I'll call on a volunteer in just a sec. I don't remember the answer, so I'm going to look also. Anybody ready? Greg.
Is it 17, 12, 7, 2?
Yeah, that's what I got. Awesome. We both got it right because I trust Mr. Hayes from last year got it right because my students would have told me I got it wrong. All right, we got another problem. So again, somebody else, I'd love to call on you. Somebody else. It's great. I use paper for these things. It doesn't hurt to do that. Three times? I said, what is output?
Oh, what's output? Oh.
0, 1, 2. Correct? Yeah, it runs 3 times. But it prints the 0, the 1, and the 2. And one more. What's output by this code? Caleb. Boom. Nothing is printed because I is not greater than 3, so it doesn't even go in. So that's just an example, and people often make this mistake. They're like, Mr. Hayes, my code's not running, and it's just not doing my loop. And then we look, and I'm like, you remember the alligator's got to eat the bigger number. So if I starting out at 0, then you do the alligator eating the 3. Anyway, all right. So we're going to redo that warm-up we just did, but with a for loop. And then I have a little practice trouble that has 4 for loops in it.